General wave properties. The transfer of energy. Waves transfer energy from one place to another without transferring matter. So you can put this in a real life example by saying, for example, if a pebble is dropped into a pool of water and the ripples move outwards. And let's say there was an object such as a leaf on the water. The leaf wouldn't move forward, but it would only move up and down. So that explains the statement that waves transfer energy from one place to another without transferring matter. Frequency, wavelength, and amplitude. Frequency is basically the number of waves produced each second, and it's measured in hertz. Amplitude is the maximum height of the wave from equilibrium position. It's shown in the diagram, so it's basically from here to here. Wavelength is the distance between a point on one wave to the same point on the next wave. This is also shown in the diagram, so it's basically here to here. Or it can be, or it can be here to here. The wavelength is measured in meters and is symbolized by the Greek alphabet lambda. Wavelength and frequency have an inverse relationship, meaning that the higher the frequency, the lower the wavelength. The wave equation. So basically you will need this equation for many calculations. V is equal to F lambda, where V is the speed of the wave, frequency F is the frequency of the wave, and lambda is the wavelength. Transverse waves. The up and down motion of this wave is at a right angle to which the wave propagates. That's the definition that you will need to know. Examples of this wave include radio, microwaves, infrared, visible, ultraviolet, and basically all the EM waves. Longitudinal waves. In longitudinal waves, the displacement of the medium is parallel to the propagation of the wave. An example of this type of wave is a sound wave. These types of waves also have compressions and rarefactions. Compressions it's this region here, and it's a region of high pressure where the particles are really close to each other, and rarefactions are regions of low pressure and the particles are far apart. Reflection occurs when a wave meets a boundary. So you need to know that the law of refraction, which states that the angle of incidence, so this angle here, equals the angle of reflection, this angle. Refraction. Refraction is the bending of the wave that occurs when it passes from one medium to another. This bending occurs due to a change in speed when it goes through the medium. So you can see it goes from one medium to another, and the light bends at a different angle. So you need to know that light passing from a less dense to a more dense medium bends towards the normal, and light passing from a more dense to a less dense medium bends away from the normal. Diffraction. This is a phenomena that occurs when a wave goes through a slit and the wave spreads out, and this is called diffraction. The smaller the gap and the longer the wavelength of the wave, the bigger the spread. And the larger the gap or the shorter the wavelength, the smaller the spread. Thanks for watching.